So what are our quadrants? And I forgot to mention this in the other hour. And again, hopefully college students in the future here, you can focus with me here as we keep going with this. But I think everyone knows that's one, right? Which way do I go next? Do I go left or down for quadrant two? Left. And I'm just going to tell you right now. And actually, this is shortly going to be affirmed, I guess, that math counterclockwise seems to be the norm. It is. It's weird. And almost everything that we deal with when we move around circularly. So I call that normal because normal you would count one and then two. That's the normal progression. So counterclockwise, remember that. And then what is our acronym? Ka Toa. All right. And then you know what? It's gonna come up here. Who's a hoe? Who's a hoe? Who's a hoe? Come on, tell me. I don't have to keep saying it. Who's a hoe? Co no co secant. So what does that mean? Who's a hoe? It's just the flip of sign. And this is a definition. Somebody first hour just getting dumbfounded by this. Like what is going on? It's just a definition. How many fingers do I have? How many fingers do I have? Wrong. I have 10. How did you get that wrong? All right. Oh my gosh. They can't do anything in this class. All right. Just kidding. Just kidding. It's a joke. Don't get offended, Jacob. Jacob got a mention. All right. And then what's cosine's reciprocal? See anyone? Secant. All right. I'm going to do this now because it flips in the notes later. It just like shows up. When in reality, the AP, and I'm sorry, I know this jumps around. Yesterday we were talking about periodic and and that should have been like in the graphing part. We're not graphing before our next quiz. So I feel like AP kind of like chops around. So just get ready for the choppy waters. And we're trying to stick in that order. And then cotangent, that's the shorthand which we defined on Monday or Tuesday. So I did introduce these other three. Anyone in the regular program, you've never seen the other three. Hey, it's just a definition. They're reciprocal functions, flips. Next one. Okay, remember I told you about normal as counterclockwise? What's wrong over there? What are you doing? Okay. All right. So, what would be a reasonable angle? Well, let me not go too fast. Okay. So, you regular students that never probably seen coordinate trig before, these are the rules. From now on, when we give you an angle measure and coordinate trig, the angle always has to start on the positive x-axis. That's the beginning point or beginning side. You need two sides for an angle. And you just got to get it. We got to lock this in. And then what's the word terminal mean? What does the word terminal mean? Starts with an E, and then there's an N, and there's only one more letter. Help me help you. There was one more letter. English is a lot more letters. End. They're just throwing out words at me. End side. Okay, so terminal side is end side. So in regular geometry, you probably never went over 180 for an angle measure. Now we're going to get nuts, and we are. But this one isn't. Wouldn't you agree that if I put a protractor on this, somewhere around 117, I just made up numbers. But when you agree it's over 90, right? Okay, if you don't have that knowledge, there's the door. All right. I can't deal with some of these things that we don't know. All right. And then and that's positive because I went counterclockwise. So that says that down here on the bottom. Boom, right there. Okay, so that angle measure is positive. All right. And I might highlight that positive because I'm going to actually do this quite a bit here. And then I'm going to color this in green because I'm going to make green negative. And maybe I'll highlight in green. Oh, I just knocked those over. All right. So now when I go this way, it's an angle measure. Let's say we measure it and it's a little bit different than this one. Let's say it's like 119. But wrong. I went clockwise, so that is a negative angle measure. So you need to know how to move in a coordinate plane and what a positive and a negative angle measure mean. It's just direction, and that's it. It's not rocket science. Although trigonometry is used in rocket science. And then I said in my other class, hey, let's do this. So when I said I would do this, theta is negative, and then I'm drawing in negative measures. Hey, what's that green angle measure then? Well, what do you think these two should add up to become if they were both positive? 360. So it isn't rocket science, although it is. I know what math shirt I'm gonna wear next Wednesday. It's about rocket science. What's 360 minus 117? Isn't that negative or negative 243? Is that right? And actually, I should have said, what's 117 minus 360? Isn't that negative 243? Am I right? Does anyone do any math? He's using his calculator. Oh, all right. And then this angle measure, be nice over there. This is why I wanted different angle measures. He's still calculating. Is it? He didn't do it. He was just going. Then he passed out. All right. 241. It's Jacob again. And it's positive. Everyone okay over there? This group looks so sad over there. Now, you can go and read those directions. Where does 60 degrees land? What quadrant? 1, 2, 3, or 4? Come on. Everyone should know like 60 degrees would look like this. So there's 60. Negative 90. Which axis would I land on? Positive or negative? X or Y axis? Negative Y, because you have to start here and then go to here. I don't understand why students, like people that know the unit circle, just went ugh when it was mentioned on the previous video. It really isn't that hard. Positives, negatives, moves. Why you don't like it is we're going to radians, which are fractions. That's why you don't like it, because you don't like fractions still. That's why I've been a fraction jerk. Well, I've been a jerk in a lot of ways, but a fraction jerk for sure this year, because now we're on it. Hey, where does 240 land? Quadrant 1, 2, 3, or 4? 3. Everyone should know, do this, do this, do this, do this. What's that angle measure right now? So you should always think this way. You don't ever have to draw it like this. Okay, and then how much farther do I have to go? How much farther do I have to go? 60. We should be able to get 60 out of that. Hey, remember Tuesday? 30, what? 30, 60, 90. That's a 30, 60, 90 triangle I can draw in quadrant 3. And then that's when we start getting into what you're going to have to know. So that's why you got to do your homework. Everything builds on itself. And that's why I gave you that over and over and over again. What's the sine of 30? What's the cosine of 30? What's the tangent of 30? Even when the sides were different in each triangle, you came up with the same ratios. What do you got to do about 570, first of all? What do you think you got to subtract out of there? 360. So you got to break this down and figure out what's left over. And we're not going to get the calculator out. If you can't get 210 out of there, there's a problem. But really what you should do is this. You should draw your 360, get that out of the way, and then where does 210 land? What quadrant? 3. By the way, what's that angle measure that I just drew second? 180. So I'm trying to figure out what's left over. 180 and then what's left over? Guess what you got there? You got a 30, 60, 90 triangle you can draw in there. This is the kind of game you're going to play. Unfortunately, AP is radians only, so we're not going to talk about degrees like anymore probably. So we're going to have to convert this into radians eventually. All right, here's what all this is. I don't have time to go through all this and read it with you and tell math stories and all this other stuff. Very, very, very wordy, but this is what they're trying to get you to understand. When I draw a triangle in any quadrant, this side is always X. This side is always Y. That's just how you move for a coordinate. All right. And then she made the connections, what, happens with, when it's a unit circle, which is what we're really going to get to. But then what's this side called for the angle measure? And this angle is right here. It's in this little spot. It's actually called the hypotenuse, but this is a circle. So what is this for the circle? The radius. So R will be used for that side measure. Now, you're not going to like this, and I don't understand. This blew someone's brain gasket last hour. All right. And I don't get it because it's really not that hard. By the way, for theta, maybe I'll put this in different colors. This is the opposite side of that angle. This is the adjacent side of that angle. And this is the hypotenuse. It really does upset me how people make things more complicated than they need to be, because you're going to have to do what I'm going to do next. What sign? What letter over what letter? Opposite over hypotenuse. But what did I just replace opposite with? What letter is the opposite side? Y. And what do we call the hypotenuse in that circle thing? The radius. This really drives me nuts how people make this a big deal. And then adjacent over hypotenuse. But what is the adjacent side always? X and what? And R. And then what's tangent? So, which is what? Y over, oh, I reversed those colors, sorry. Right? I was doing the green for now I'm in a loop and I can't get up. Don't be turning that page yet. Turn that right back over to that other page. How dare you? Because here we go, and you should know what happens next. So what's the acronym? The acronym in green is say it. TOA. That's gone. Because why? What is the opposite side? Look over here. What's the opposite side? Y. Maybe that'll get the thing going. What do we call the R? What do we call the hypotenuse? Darn it. R. And then what is the adjacent side? X. And then what's the hypotenuse? R. And then what's T? Well, so here we go. Sir, say it. Kickser, say it. Ticks. Sir, Kickser, ticks. Say it 5 times. 3, 2, 1, go. This sounds like a really disturbing cult. All right. Sir, Kickser, ticks. Sir, kicks. This group said nothing. All right. All right. Now try example 1. Just give me the angry eyes. Now, it's a reader. So the person that made these notes wanted to remind you of the sadistic AP questions. I said it. I don't know why you have to have such complicated questions with complicated wording. Jacob, read that question and try to answer it right now. Jacob got 3 mentions. And actually, it's probably more complicated than it needs to be. I do want to give it a time to read. So it's a multiple choice question, I think in the AP kind of format. And it actually is the verbiage of our AP video I showed from, it was AP 3.2 second video we did today. I should have done tomorrow's notes today, the way I like things. That might really shorten what they're doing for notes, the other teachers, because this is even long today. And of course, I'm just kind of talking while you're reading, which I'm sure is helpful. Can you at least raise your hand if you've guessed an answer, have at least an educational guess on an answer? Okay. All right. And then I'm not going to give you the answer, but really, you know, when I look at a multiple choice question, I see a lot of words. I do scan it. And really, the only important part of it is this. This is really the only thing that disseminates what the right answer is or not. That's really all you have to look at. Which one is the right cosine ratio? Is it A, B, C, or D? It is A. Because A, didn't we just say A is well, it's Kickser, right? I just literally went over that. I just literally gave you the new acronym, and look at the numerator of cosine of theta. It's X over. And then how do we get 3? Well, look at this. The radius of this circle is 3 from here. So this is 3. And then that's X and that's Y. This is cosine. Cosine is X over R, X over 3. All the other ones have the wrong ratio, so there's no way they could be correct. All right. Anyway, we're going to move on from that. Again, it's I think a complicated, worded question, but it has all the vocab from the AP video that I showed you about horizontal and vertical displacement, and cosine is horizontal displacement. All right, now this one's a little bit tricky, so I'm going to kind of help you read through it and then know what it is. Okay, so that is this line. So that's the slope of this line going all the way through, and this line passes through that point. Okay, got it? And what slope? This was terrible first hour. 2 letters that start with R. Slope is rise over run. What's rise? X or Y? Y. So this is saying that this runs and then rises. So I know that it's it has a run of 7 and a rise of -5, or it's a run of -7 and a rise of +5. But then we got a problem. This coordinate is x comma 15. This doesn't really coincide with each other real well. That's that point. So if I go left 7 and up 5, that doesn't hit that coordinate. So really it's just this. -5 over 7, that equals 15 over what? Because that's what's missing is that x coordinate in order for me to get there, right? And basically it would be -2, and actually the x is really negative, not the y. So what is that x value? It's just a simple common denominator thing. What's the answer to that? 3, 2, 1, go? No. Haven't heard the answer yet, seniors and juniors. 5 times what equals 15? 7 times what equals blank? So what's the answer for x? -21. Okay, that would have to be the case for this to have a slope of -5/7. All right, so just solving this simple proportion. Again, I think this is an AP type question. Kind of complicated, but it really is based off a slope. I don't want to spend a lot of time on that. This is the main idea. Okay. So first of all, I have an angle measure. What's this angle measure between what 2 angle measures? Oh my gosh. This is between what 2 angle measures? Teaching in America. 90 and 180. Okay. Again, can't force your participation. All right. And then we have to understand that this is a triangle. So this is actually -3 and this is 1. How do you think I'm going to find that side that's missing? Something that we practiced on Monday, Pythagorean theorem. So maybe we can do this fast. -3 squared is 9. 1 squared is 1. 9 plus 1 is 10. And then you square root it. I'm not wasting time on teaching Pythagorean theorem to seniors and juniors. Not going to happen. All right. X, Y, R. And what is sine from what I just taught you? Well, from here on out, at the top of a test, you're going to write this acronym. Not SOHCAHTOA. You could, because SOHCAHTOA would work, but you'd have to understand that this is the angle measure that you play SOHCAHTOA with, that one right here. So this is opposite, this is adjacent, this is hypotenuse. So sine, just to speed this up, would equal 1, the y value, over √10, the x value. I'm sorry, the r value. Yep, caught myself there. And then I'm not going to show rationalization every single time. This becomes √10 over 10, and then hopefully pattern recognition takes the place when we do the next one. Cosine is -3 over √10. And then you should start understanding pattern recognition. When I rationalize, the root goes up on top, the bottom is free from a root. All right, and that should be quick. Tangent is -1/3, or y over x. And you could just write -1/3 out in front. And then we really should, but we have it later, do the other 3, which blew somebody's mind last hour. Like, where are you getting this from? The secant, cosecant, cotangent. We actually talked about it Monday. All right, that's alpha. Get used to the Greek letters. So sine, cosine, and tan. By the way, what is this circle called? The unit circle. So actually, this is when, and I can prove it, this is what cosine is. And this is what sine is. This goes back to the AP video, what the lady made a final connection with. Because it's simple. Sine of theta would equal that y value, negative 0.76, divided by the r value, which is 1. So therefore, I would just get negative 0.76. The cosine value would be that x value, because I could draw a triangle, yoink, yoink, and then this would be negative 0.65. This would be negative 0.76. So I could place SOHCAHTOA there. Back to the previous one. So opposite over hypotenuse, which is 1. Ka adjacent over hypotenuse, which is negative 0.65 over 1, which is negative 0.65. I'm just showing you that idea. And then go ahead and get your calculator to get this decimal, negative 0.76 cosine. I'm sorry, sine over cosine, which is another identity that she said, or y over x. And then beep boop, get your, I'm not here to teach you calculator work. We got to move on. Okay, now it's to this one, and this is where I stopped with the other class, and I think I might do the same with you. Because I think these are more the same, and just there's too many examples, just way too many, just too much. But I do want to remember those 6 trig functions. Okay, so first things first, let's manipulate our triangle a little bit. And I don't know if the other ones are doing this, but I just like doing this. Okay, you want to go X, Y, R. You really want to think about this as triangles, and then those that can stick with SOHCAHTOA, you'll be fine. SOHCAHTOA is really good. All right, so what did I go right? I went 2.6 right, and then I went negative 0.54 down. And then I see this point right here, which means this hypotenuse is 6. I did that again. I moved that decimal. I did that last hour. 0.54 instead of 5.4. I don't know what's going on with my brain there. All right. So, and then hopefully that does work out for the Pythagorean theorem. She made a mistake on her AP video on that value. We don't really care. We'll just answer this. So sine, I don't know why that even happened. Sine, lost everything. Great. Cosine tangent is what we're going to write first. And I told you, and I know this could be tough, but we should put this at the top of every sheet that we're working on, this new acronym, and not make a big deal out of it. It was just making a replacement of letters for SOHCAHTOA. Okay, so cosine, or sine, sorry, is that y value, negative 0.5 or 5.4. I did it again. Over 6. And then beep boop. I'm not here for the calculator. Type it, press enter. And by the way, we're not finding the angle measure. We're just knowing what the ratios are for each trig function. It's really a wax on, say it, wax off, kind of just, knowing what is what for each trig function. And then it's 2.6 adjacent over hypotenuse. You said I couldn't say that. Well, I do have a triangle. And I do know that this is the angle measure in question for opposite adjacent hypotenuse. So this is a survival technique for you. All right. And then beep boop calculator. And then tangent is negative 5.4 divided by 2.6. Beep boop, press enter. Okay, you can get those decimals just fine. Now, who's a hoe? Cosecant. Why do I say cosecant's a hoe? Because cosecant is the flip of sine. Sine is so, cosecant's a hoe. So therefore, this is all it is, cosecant's definition. It's just the flip of sine. And then beep boop, press enter. Someone got blown away first hour. It's just a definition. How many fingers do I have? 10. All right. Who's the flip of cosine? Secant. So it's just the flipped fraction of cosine. relationship of sides. This is what trig is, relating sides to angles through a math algorithm. And then these are the 6 that they decided to come up with. Who's they? The ancients. And it's not just like so many different civilizations, not even related to each other, did come up with some format of this kind of idea, right? All right. You can tune me out. I already have. I'm going to kind of go through the rest of these just for video purposes. Second quadrant, sine of theta is 0.3. Find cosine and tangent. By the way, 0.3 is 3 over anyone? 3 over anyone? 3 over anyone? 0.3 is 3 over anyone? 3 over anyone? 3 over. Someone say this number I'm about to write. 10. So guess what that is? That's why. That's our boom shakalaka. So if I drew this out, it says it's in quadrant 2. This is what I have in this triangle. I have 10 and I have 3. How do you surmise I'd find the missing point? By the way, how did I get 3 over 10? 0.3 is read as 3/10. Right? How would I get that last side? The Pythagorean theorem. 10 squared is a hundo. 3 squared is 9. So 100 minus 9 is 91, and then it's square root. But lies. It's negative because you went left and then up. So you really should think about this in a coordinate plane. Okay, so what's cosine of theta then? X over R. I'm sorry. Yes, it is X over R. Sorry. My brain's a little cloudy today. That's good. I don't have to do anything there. And then tan of theta is unfortunately 3 over negative root 91. I didn't even check 91. I think 91's prime. 90, 9 and 10 go into it. 91, I'm pretty sure that's prime. So no need to simplify that. But hey, remember what I said about rationalizing? It's 3 root 91. The root goes on top. The free one goes on the bottom. This is how you can always rationalize super fast. It's kind of an algorithm. All right. I really am going to stop. I think this is over ambitious, all these different things here. Too much.